We welcome you all. Today we are going to see the problem in the topic of cooling load estimation. Here, the objective of the problem is to find the total cooling load in the conditioned space and decide the size of the air conditioning unit. In finding the cooling load calculation, we consider all the factors that we have discussed in the previous classes and calculate the cooling load. Here the problem. For the conditioning of a 4-meter high single story office building located at 30° north latitude, the plan of which is shown in figure, the following data are given. This is the plan of the single story office building. This is the outside walls. Outside wall, the size of the wall is length 27 meter, width 17 meter. This is the partition wall. This is door of the single story office building, and these are the windows of the single story office building. The given data are plaster on inside wall 1.5 centimeter and outside wall construction. That is the composite wall 20 centimeter concrete block, 10 centimeter brick veneer. Partition wall constructions are 30 centimeter brick. The roof construction 20 centimeter reinforced concrete cement slab with 4 centimeter asbestos cement board. The floor constructions are 20 centimeter concrete, and they gave the densities of the brick, concrete, plaster and asbestos board. The fenestration, they gave the fenestration size and the heat transfer coefficient at the windows U equal to 5.9 watt per meter square Kelvin, and they gave the door size and the overall heat transfer coefficient of the air at the door is 0.63 watt per meter square Kelvin. Outdoor design condition is 43 degrees Celsius dry bulb temperature, 27 degrees Celsius wet bulb temperature. Indoor design condition is, that is a design temperature 25 degrees Celsius dry bulb temperature, 50% of relative humidity. Daily range 31 degrees Celsius to 43 degrees Celsius. That means the variation of temperature on the outside of the single story office building, the temperature varies from 31 degrees Celsius to peak temperature 43 degrees Celsius. Occupancy 100. That means number of persons in the office 100%. Lights equal to 50,000 watts. That means the number of light that emit the power, the total watt of the power light is 50,000 watt. Assumed bypass factor of the cooling coil 0.15. Here the question is find the room sensible and latent heat load and also the grand total heat load. Solution. They take the thermal conductivity of the glass and concrete, brick, plaster, asbestos from the table. They give the values and assumed film coefficients. Film coefficient of the air F0 23 watt per meter square Kelvin on outside air, inside air F5 7 watt per meter square Kelvin. Outside wall. Next, for the first step is we are going to find the overall heat transfer coefficient of the outside wall. We consider both the convective resistance of the outside air and inside air and the thermal resistance of the composite wall. Next, we are going to find the heat transfer coefficient at the partition, that value is 1.86 watt per meter square Kelvin, and heat transfer coefficient of air at the roof, the value is U equal to 2.13 watt per meter square Kelvin, and finally we find the overall heat transfer coefficient of the air at the floor. The 40 floor U value is 6.05 watt per meter square Kelvin. Then we find the area and volume of the office, single story office building. Then the ventilation rate for office. From the table we flow rate, volumetric flow rate of the ventilation is 0.28 cubic meter per minute. Here the total volume of ventilation air is 0.28 times 100 per person, 0.28 cubic meter per minute. So total 100%. So volume of ventilation air is 28 cubic meter per minute. Next we are going to find the mass of wall per unit area. So outside wall mass, we find the outside wall mass, that is 604 kilogram per meter square. Mass of partition wall 707 kilogram per meter square. Mass of the roof 401 kilogram per meter square. Then problem, they observe the solar radiation on the windows in watt per meter square unit. So they calculated from they gave the data in the table, and we find the area of the doors, let's say door, and area of the windows. Outside wall area, the outside wall area, west side wall area 96 meters square, north side wall area, south side wall area, partition wall areas of east side wall, north side wall. We calculate the areas of the outside wall areas, partition wall areas. They gave the occupancy load, sensible heat load 75 watt per person, latent heat load 55 watt per person. And we assume the only 10% of the supply duct outside the conditioned space. The second assumption is no return duct outside the conditioned space. Then the third is the fan horsepower is 50% of the RS value. Next we are going to see the calculation sheet for cooling load estimation. So this is the calculation sheet. First one, we find the space of the office, and the estimation time is 5 p.m. up to 5 p.m. The outside condition of the air 43 degree dry bulb temperature, wet bulb temperature 27 degrees Celsius, relative humidity value 29%. And the indoor desired conditions are 25 degree Celsius dry bulb temperature, 18 degrees Celsius wet bulb temperature, 15 degrees Celsius, 50% of relative humidity value. The ventilation, next we give the volume of ventilation air 28 cubic meter per minute to 28 cubic meter per minute. Next the sensible heat calculation. First the solar irradiation, east side glass, there is no solar radiation. West side glass, the value is 5900 watt per meter square. North side glass 270 watt per meter square. South side glass 190 watt per meter square. Next the solar transmission gain wall and roof. Next we going to consider the heat transfer through the walls and roof. So we calculate all the values in watts. Next we find the heat transfer solar radiation through the doors and all glasses and partition walls. Next we focus on internal heat gain. 100 people, so the sensible heat load 7000 watt. The lights 1500 watts, so we calculate the sensible heat load value. So here we consider the factor, so 5% of the value. So supply duct, here we calculate the heat gain through the duct. So here in the problem 5% is 5% plus leakage value. Next he consider the effective room sensible heat, the infiltration value. the heat gain due to infiltration is 5940 watt, and the latent heat value, latent heat of the people 5500. The total value is 11,400 value. So the final this is the final effective room latent heat value 13,330 watt, and the total load is, the grand total is the summation of sensible heat load and latent heat load. The total load is 1 lakh summation of sensible heat load and latent heat load. In this problem, the many designers don't take into the account of the infiltration load separately. They usually consider to be they usually consider the inflation in the, for example, in many designers don't take into account the inflation load separately. It is considered to be taken care of by ventilation air. If the ventilation cubic meter per minute is greater than the inflation cubic meter per minute, on such simplified load estimation calculation sheet for the ground, first and third floors of a television studio building without considering the infiltration load. So this is the problem in the cooling load calculation.